So how can we have the unit vector of a vector? So what is a unit vector? So this is a vector with magnitude given as 1. And let's say we have a vector given as a vector A. So before I go much in details about the unit vector, you should have to understand about this. Well, okay, let me just have to highlight you about this one. Let's say we have a vector A, and let's say in unit vector notation we have it as 2i in the plus 5, let's say j, minus 2, let's say k. So what is the magnitude of this vector? So according to the principle behind, we'll have 2 to the power 2 and the plus 5 to the power 2 and the plus negative 2 to the power 2, and that will be given as the square of, now should be 4 plus 25 and the plus 4, and that which is equal to the square of, now should be 25 plus 8. So what is that one? What is 25 plus 8? So now 25 plus 8, we can have it as 33. So which means the magnitude is given as 33. So as you can see, a vector A is having the magnitude of a square root of 33. So how can you be able to have actually a vector A to have the magnitude of 1 other than 33? So that one is what you call a unit vector. So how do you find the unit vector of a vector in that case? So let's say the unit vector is given as u. This is equal to a vector A divided by its magnitude. So that's how we find the unit vector of a vector. So that is the ratio of a vector divided by actually the ratio of a vector to its magnitude. So in that case, this is the same as, now should be, this is the same as, now the x component of a vector A divided by the magnitude of its magnitude, and a plus the y component and divided by its magnitude, like that, and also up to the z component as well. So take note of that. And in this case, let's say we have, and the unit vector, and the direction of the unit vector is the same as the direction of the vector itself. Let's say we have a vector m, and which is given as, let's say 2, 4, let's say 2. Let's say that's the case. So what is the unit vector of a vector m, let's say given as a? So have it as the vector m divided by its magnitude. So in this case, we'll have it as, we'll have what is the magnitude of the vector m. So that will be given as the square of, now we'll have it as 4 plus, should be 16, and plus 4, that which is the same as 24. Now have it as the square of 24. So which means the unit vector, which is given as the vector A, will be given as actually a vector 2, 4, and 2 divided by the magnitude given as the square of 24, and of which this is the same as the vector A is equal, now should be 2 over square root of 24 and comma 2 over square root of 24 and comma, let's say 2 over square root of 24. So that is the same as that. So as you can see, you'll be able to see that the magnitude of the vector A will be equal to 1. That is the Now that is the unit vector. In the arrays, the magnitude is given as 1. And for instance, let's say we have a vector A, and which is given as, let's say, 2i and plus 3j, and let's say minus 3, let's say k. So what is the what is the unit vector of the vector A given as u? So in this case, we'll have it as a vector A divided by its magnitude. So that is the same as what is the magnitude of the vector A? We can have it as, should be now 4 plus 9 and plus 9, which is the same as 18 plus 4, that will be given as 22. So which means the unit vector of actually a vector A, that should be given as a vector u is equal to, now should be 2i plus 3j minus 3k, and that divide by the square root of 22 and the square root of 22 and also the square root of 22. So which is given as that. And you understand that the magnitude of this vector will be equal to 1. That is the unit vector, and it is in the same direction as a vector A. So take note of that. So now what if we'd like to have a magnitude other than 1, but for the unit vector of a vector A? So which means, let's say if we'd like to have a vector u to have the magnitude, let's say, given as 2, we'll have to multiply this one by 2. Let's say to have a magnitude given as 5, we'll have to multiply this one by 5. But the direction will be the same as the direction of the vector A. Let's say if we like to have it in the opposite direction, in opposed to, let's say, the vector A, it means we'll have to multiply this one by, let's say, a negative. And let's say if you like to have it in the opposite direction, but should be should be, let's say, the distance given as 10, we'll have to multiply this one by a negative 10, so that the direction should be opposite to the vector A, and the magnitude should also be given as 10. So that's how you have to understand about the unit vector of a vector. Now think about this. Let's say we have a vector D, which is given as 20i minus 16j and plus 2k. Let's now find the vector from this vector. Find a vector which is now in the opposite direction with this vector, but should be of a length given as 20. So try to have that vector.